Polly the Polynomial Penguin here, talking to you about adding and subtracting polynomials. There's a question. Who's the penguin's favorite relative? Antarctica!
First vocabulary term is a polynomial. That's an expression containing several algebraic terms. So here you can see we have 4 different polynomials. Now, these polynomials, again, have multiple algebraic terms, and the algebraic terms are going to be separated by plus and minus signs. So here you can see this has 1, 2, 3 terms. This polynomial has 1, 2, 3, 4 terms. This one has 2 terms, and this one has 1, 2, 3 terms. If you're trying to figure out how many terms a polynomial has, just know that the minus and plus signs separate those terms, which will make it way easier to count them. Now let's talk about the degrees of a polynomial. So here's how you determine what the degree of a polynomial is. You're going to look for the variable or variables, and you are going to look at the exponents of your variables. In this case, we'll start with the constant. A constant is degree 0 because there is no variable, which means the variable technically has a degree 0, which turns it into 1, which makes it not even there. That's why a constant is degree 0. It has no exponent. If it did, the exponent would have a degree of 0, making it 1. A linear polynomial. That means that the variable has an exponent of 1. So in this case, we have x to the first. In this case, we have m to the first. That's why each of these are linear polynomials. Now let's get into quadratic polynomials. Those are degree 2, which means that your exponent of one of your terms has to be 2, and that exponent has to be the biggest of each of the terms. So here you can see this exponent is 1, this one is technically 0. So yes, this is the biggest exponent, therefore we classify this particular polynomial as quadratic because the highest exponent is 2. You could have also technically had this be x times y, or a times b in the front. If it's a times b, that's also a quadratic because it's technically a to the first, b to the first. Those exponents would add up together and give you a degree of 2. And we'll get into that in the next one. Here, you can see cubic, it's degree 3. Now you could have just 15x cubed. That is a cubic polynomial. In this case, we have 15x to the second, y to the first. And that is the highest value of exponents added together in this case because this is technically x to the 0. So this is a constant. This is degree 3. This 2 plus the 1 gives you a degree of 3. That makes it a cubic polynomial. A quartic polynomial is degree 4, and here you can see this p squared and q squared combine to give us a 4th degree polynomial, a quartic polynomial. Since this is p to the first and this is q to the first, those are less than our degree 4, which means we classify it based on the biggest degree in this case, the term with the highest degree. Quintic polynomial is where you have your term with the highest degree being a degree of 5. So in this case, we have m to the first, n to the fourth. The 1 plus the 4 gives you a degree of 5. This is a constant, so that doesn't affect it at all. Anything after a quintic polynomial, you're going to refer to it as whatever the degree is. So this, in this case, would be a 6th degree polynomial, all the way up until 100, a million. 6th degree polynomial and beyond, you classify it based on whatever the degree is. So it'd be 6th degree polynomial, 7th degree polynomial, 8th degree polynomial, just like that. Now, let's talk about the number of terms. How do we classify based on the number of terms? We've talked about classifying a polynomial based on its degree, but how do you classify based on the number of terms? If there are no plus or minus signs, you're going to call that a monomial. It's one term. It's a singular term. So here we have 8. Here we have 3x squared. Each of those are monomials. That means mono is 1. Bi means 2. That's why a binomial has 2 terms. Here, you're going to have 1 plus sign or 1 minus sign. And here, since it's 5x to the fourth plus 3, each of those represents 1 term. So 2 terms, binomial. Trinomial. Tri means 3. So 3 terms, we have x squared plus 6x plus 2. 1, 2, 3 terms. A polynomial. Anything beyond a trinomial we consider a polynomial. So a polynomial has 4 or more terms. So here you can see 5x to the fourth plus 6x squared minus 7x plus 12. We have 1, 2, 3, 4 terms. We're just going to call that a polynomial. Even if it had 5 or 6 or 7 terms, it's a polynomial. to classify a polynomial, what we're going to do is we are going to classify it based on the greatest degree and their number of terms. So those two vocabulary tables that we just looked at, that's how we're going to classify a polynomial. So let's go ahead and do this. In this case, we have 1, 2, 3 terms. So that is going to be a trinomial. Now, what is the greatest degree in this? That would be this 2 right here. So technically, this would be a quadratic trinomial. Here, what's the greatest degree? That would be this k to the 4th. So we have a 4th degree as our highest degree, which means that would be a quartic polynomial. Now, how many terms does this have? 1, 2. So this would be a quartic binomial. Here, what is our greatest degree? This is degree 2. This term is degree 2. This term is degree 2 plus 1. So this term would be degree 3. This is a degree 0 because it's a constant. And this is degree 1. So our greatest degree would be this 3 right here. This is a 3rd degree polynomial. Now, how many terms does it have? 1, 2, 3, 4. So 3rd degree means it's a cubic, and then 1, 2, 3, 4 terms means it's a polynomial. So this is a cubic polynomial. Lastly, we have 1 term. That's easy. So that's a monomial. And then what is the greatest degree? Well, here we have x squared and y to the 3rd. So to figure out the degree, you just add those exponents together, we get 5. So this is a quintic monomial. Let's talk about the standard form of a polynomial. So polynomials arranged from greatest degree to least degree are in standard form. So we just need to arrange the terms based on highest degree to lowest degree. So that's easy. Here, if we were to rearrange this into standard form, we would put our degree 2 first, we would put our degree 1 second, and we put our constant last. Here, this is a monomial. There's no way to rearrange this. Okay, you could use the commutative property and move this around, but this is the way you would write that. You want your constant in front if it's a monomial, so you just leave it like this. Here, greatest degree to least degree. So our greatest degree would be this k to the 4th. Our least degree would be this constant, so you just rearrange those. And then here, we want to go from greatest degree to least degree. So this negative m squared n to the 1st, we said that was our greatest degree. So that's going to go first, followed by 5n squared, followed by our 4m, followed by our 11. Greatest degree to least degree. Leading coefficient. So that's just going to be the number in front of the term with the highest degree. So whatever term has the highest degree, the number in front of that is called your leading coefficient. We have this quadratic trinomial, and we want to put it in standard form. So that's easy. We go b squared minus 2b plus 5, greatest degree to least degree. Now, what is the number in front of our greatest degree, our term with the greatest degree? That would be this 1, this invisible 1. That's why our leading coefficient is 1. Here, if I want to put this in standard form, we go from greatest degree to least degree. So 5c to the 4th plus 6c to the 3rd plus 3c squared minus 4. Greatest degree to least degree. Now, what's the number in front of our term with the greatest degree? That's this 5. That's why our leading coefficient is 5. Like terms. So those are terms within a polynomial containing the same variables with the same degree. So here's how this works. I can combine any terms that are like. So if I have like terms, I can combine those. But if they are not like terms, I cannot combine them. So in this instance, this 5x squared and this x squared are like terms, which means I can combine them. What is 5x squared plus x squared? So that's 5x squared plus 1x squared. That's going to be 6x squared. Now, I cannot subtract this 6 and this 3 because this is a second degree term and this is a constant, a 0 degree term. So you cannot combine those. Here we have 3x squared y to the 3rd plus 8xy plus 9x squared y minus 3xy. Okay, so we are combining like terms. Again, they have to have the same variables with the same degrees. So here, you would think that you could combine this 3x squared y to the 3rd and this 8xy. No, since you're adding or subtracting, you cannot combine anything that doesn't have the same variables with the same degrees. These have the same variables, but not to the same degrees. Therefore, you cannot combine these two. What about these two? Well, the x squareds have the same degrees, but the y's do not. Therefore, these two do not have the same degrees. They are not like terms. What about these two? Yeah, x to the 1st, y to the 1st, x to the 1st, y to the 1st. So those are technically like terms. We could combine those. What's 8xy minus 3xy? That's 5xy. And we write it in standard form going from greatest degree to least degree. For part C, again, we're looking for like terms. So n squared, does that have a like term here? No. What about m squared? Yeah, there's another m squared. So we have minus m squared, so negative 1m squared, plus 4m squared. That's going to be positive 3m squared. We also have 11 and negative 1. Those are like terms because they're both degree 0. They're constants. So we go ahead and combine these two and combine these two. And we end up getting 5n squared plus 3m squared plus 10, and that's it. Here, do we have any like terms? So we have k to the fourth, we have k. Those are the same variable, but not to the same degree. So those are technically not like terms, so we cannot combine those. What we could do is just write it in standard form, but that's about it. There's nothing you can combine here because we don't have the same variable to the same degree.
What did the penguin eat at the cookout? Chili! Example time.
Example 1 says find the degree of each monomial. So we're just looking for the degree. That's easy. So in this case, what is the exponent of our variable? That's 2. So this is a quadratic, degree 2. Here, our n is raised to the 8th power. So this is a degree 8 monomial. So we would just say 8th degree. 2, what degree is that? Well, there is no variable, which means our degree would technically be 0. It's a constant. And then here, 2b to the 6th, c to the 4th. What is the degree of this monomial? Well, remember, anytime it's a monomial, we add those exponents together to get what degree it is. So this would technically be a degree 10 or 10th degree monomial.
What did the cop say to the penguin when he saw him robbing the store? Freeze! You try.
Okay, doing the same thing here. So this monomial right here is x to the 9th, which means its degree is going to be 9. So it's a 9th degree monomial. Here, this monomial, we have a to the 4th, b to the 1st. To get the degree of a monomial, you add together the exponents of the variables, and here that would be 5, right? So this would technically be a 5th degree monomial or a quintic monomial. Here we have x to the 1st, y to the 1st, z to the 1st. Again, to get the degree of a monomial, we add those exponents together, and that becomes 3, right? So this is a 3rd degree monomial or a cubic monomial. Lastly, we have 8x to the 1st. So to get the degree of this monomial, it's just going to be the 1st, so it's a linear monomial. Okay, example 2, we're doing the same thing, except this time we have polynomials instead of monomials. So that means we're going to look for the term with the greatest degree, and that's the degree of the whole polynomial. So in this case, we have a binomial, 2 terms, and the greatest degree would be 2, right? So this polynomial is degree 2, and that's a quadratic. Here, we look for the term with the greatest degree. That would be this one right here, degree 3. So this would be a 3rd degree trinomial, which is a cubic trinomial. Here, we look for the term with the greatest degree. This one's 2. This one is technically 2 plus 3, which would be 5. So this is a 5th degree binomial, or a quintic binomial. Here, we look for a term with the greatest degree. That would be this one right here. This is m to the 1st, n to the 3rd. So technically, this is a 4th degree or quartic trinomial.
How do a group of penguins make a decision? Flipper coin! You try.
Okay, again, looking for the term with the greatest degree. This is degree 1, this is degree 2, this is degree 0. So it would be this one right here. This is a 2nd degree or quadratic trinomial. Here, this is degree 2, this is degree 3, this is degree 4. So degree 4, that's the highest degree, so this technically is a 4th degree or quartic trinomial. Here we have 2 terms, and this one is degree 2. This one is technically degree 3, right? X to the 1st, y to the 1st, z to the 1st. So if we add those together, that's degree 3. So this would be a 3rd degree or cubic binomial. And then lastly, we have q to the 1st, and then 7. This is technically 0 degree. It's a constant, and this is the 1st degree. So this is a 1st degree or linear binomial. Example 3 says simplify if necessary. Then write each polynomial in standard form and classify each according to their degree and by number of terms. So first, simplify if necessary. Not necessary, it's just x squared. Then write the polynomial in standard form. That's just x squared. Then we need to figure out what the classification is based on degree and number of terms. So this is a degree 2 or a quadratic, and then how many terms? Just 1. So it's a quadratic monomial, and you're done. Here, again, we need to write it in standard form first. So we go from greatest degree to least degree. We also need to combine like terms, right? This negative 6a and this a to the 1st are technically like terms. They're the same variable with the same degree. So we can combine those. What's negative 6a plus 1a? That's going to be negative 5a. So this becomes negative a to the fourth minus 5a plus 2. Now the question is, how do we classify this? Well, it's by degree and number of terms. So degree would be 4. So it's a quartic. And then how many terms? 1, 2, 3. So it's a quartic trinomial. Next, we have 5. That doesn't need any simplification or standard form. It's just 5. So how do we classify this? Well, it's just a number. It's a constant. There is no number of terms. There is no degree. The degree is 0. So we just say it's a constant. Lastly, this guy right here. First, we need to simplify if necessary. Nope, not necessary. We have x to the first, y to the first. We have an x, we have a y, but 1, 2, 3, 4, 5. None of these 5 terms have the same variables with the same degrees. This looks like it could combine with this, but since this is x with a degree 1 and this is x with an exponent of 2, those would not combine. So we just rewrite it in standard form. Greatest degree to least degree. This is the degree 2 term. This term has a degree of 1. This one degree of 1. This one degree of 0. This one has a degree of 3, right? The 2 and the y to the first. So this term has a degree of 3. So we're going to go this one first. So it's going to be x squared y. Then this one plus 5xy. Then you could write either of these in either order because they're both degree 1. So it doesn't matter which one comes first. And then finish with the constant. Now the question is, how do we classify this? So how many terms? 1, 2, 3, 4, 5 terms, right? So 5 terms is just a polynomial. Now what is the degree? We said the highest degree would be 3. So this is technically a cubic polynomial.
What can the penguin take apart his Legos? He glues them together. You try.
Okay, doing the same thing. First, simplify if necessary. Do we simplify this? Yeah, actually, it has 2 like terms, the a and the 5a. How do we combine those? What's a plus 5a or 1a plus 5a? That's 6a. So we have 6a and then we have b to the fourth. So which term comes first? Well, that's b to the fourth, right? That's the highest degree. So if we're writing it in standard form, b to the fourth plus 6a. Now the question is, how do we classify this? So we classify it according to degree and by number of terms. So what's the highest degree? Term with the highest degree would be this 4. So it's a 4th degree or quartic and then 2 terms, binomial. Here we have m squared minus 1 plus m. So can we combine anything? Can we simplify this? No, there's actually no like terms. Remember, like terms, same variable with the same degree. So this is the same variable, but different degrees, right? This is degree 2, this is degree 1. So you cannot combine those. So instead, we write this in standard form, going from highest degree to lowest degree. We go m squared plus m minus 1. Next, we classify. So degree and number of terms. What's the highest degree? Term with the highest degree would be this 2. So it's going to be a quadratic, and then 1, 2, 3 terms, trinomial. Here we have x to the first, y to the first, z to the first. So technically this is 1 term. So to write this in standard form, it's already in standard form. It's 1 term. So you just leave it like that. Next, we classify. So how do we classify? By degree and number of terms. So what's the degree? This would be a degree, well, you think it'd be 1, but since we have x to the first, y to the first, and z to the first all in 1 term, that's technically degree 3. So this is a cubic, and there's only 1 term, so it's a monomial. For part D, we're doing the same thing. So first, can we simplify this? Well, it looks like we have some terms that have the same variables, but not to the same degree. Therefore, no, there's nothing we can simplify here. So we're going to write this in standard form. We go from highest degree to lowest degree. So which term has the highest degree? That would be this right here. This would be degree 5, followed by degree 3, and then 2, and then 1. So that's in standard form now. Now, how do we classify this? Well, what's the greatest degree? Term with the greatest degree would be this 5 right here. So this is technically a 5th degree or quintic. And then 1, 2, 3, 4 terms. Anything with 4 or more terms is a polynomial. So it's a quintic polynomial. Example 4, doing the same thing. We need to simplify first. Can we simplify anything? Yeah, we have 2 like terms. So the 7a squared and the negative 10a squared, we can combine. What's 7a squared minus 10a squared? That's going to be negative 3a squared, right? You just combine the numbers out front. Then you can add on this 9a at the end, and it's in standard form because you're going from greatest degree to least degree. Now the question is, how do we classify this? Well, we need to classify based on the term with the highest degree, so that'd be this 2. So it's a quadratic, and then there's 2 terms also, so it's a quadratic binomial. Part B, we have these two things that we're going to add together. This trinomial and this binomial we're actually adding together. So in order to do this, all we have to do is just add together the like terms. So where are the like terms? Well, we have this 5n cubed and this 18n cubed that we're going to add together. Do we have anything else? Yeah, we have a 6 and a 9 we can also add together. Perfect. So let's start by adding together the 5n cubed and the 18n cubed. When you add these together, you just add the numbers out front. So you end up getting, what is that going to be? 23n cubed. And that's going to go in front because that's your highest degree. So we got 23n cubed going first. Then the 3n, because that's a first degree term, goes next. And then your constant goes at the end, which is 6 plus 9, that's 15. Lastly, we classify it based on the highest degree. So term with the highest degree would be this 3. So it's going to be a cubic, and then 1, 2, 3 terms. So it's a trinomial. Here, we need to subtract this binomial and this trinomial. Well, how do we do this? Remember, anytime there's a minus sign out front of the parentheses, it's the same thing as if you were distributing a -1. So we need to distribute this negative. So let's go ahead and do this. We're going to take this negative and multiply it to the m cubed, the -4m, and the -1. So this becomes m cubed minus 1 minus m cubed plus 4m plus 1. Now we combine like terms. So to simplify this, where are our like terms? Well, we have this m cubed and this negative m cubed that we're going to combine together. We also have the -1 and the +1. Interesting. Okay, so the m cubed and the negative m cubed. What's 1m cubed minus 1m cubed? Well, those cancel each other out, right? What about -1 plus 1? Those also cancel each other out. So we're just left with 4m. So then, how do I classify this? Well, it's degree 1 because it's m to the first power. And then it's just one term. So it's a linear monomial. Last but not least, we have D. We're again subtracting. This time it's a trinomial and a binomial. So we go ahead and distribute this negative to each of the terms in our binomial. And we end up getting x to the third y plus 3xy minus 1 plus 2x cubed y minus xy. So here, do we have any like terms? Yeah, we actually have this x cubed y and this 2x cubed y. We also have the 3xy and the negative xy because it's same variables with the same degrees. Perfect. So let's go ahead and combine these two. What's x cubed y? 1x cubed y plus 2x cubed y. That's 3x cubed y. And then what is 3xy minus xy or minus 1xy? That would be 2xy. And then this -1 we put on the ends because standard form we go from greatest degree to least degree. Now how do I classify this? Well, the greatest degree would be this one because it's x cubed y. So this term would technically be a 4th degree term, which means the whole thing is a 4th degree or quartic 1, 2, 3 trinomial.
What do you call a penguin in the desert? Lost! You try.
Okay, doing the same thing. You need to simplify first. So here, we don't need to distribute a plus sign because it's just a plus. So we're going to add these two terms together. So how do I add? I add like terms. So here I have a -3x combined with this 2x. What's -3x plus 2x? That's -1x. I could also combine the 12 and the -18 to make -6. And then I rewrite it in standard form going from my greatest degree, this 9x squared minus 1x minus 6. Perfect. Now, how do I classify this? Well, what's the greatest degree? The term with the greatest degree would be this one with the 2. So it's a quadratic. And then 1, 2, 3 terms, trinomial. Here, I need to distribute this -3 in order to simplify this first. So let's distribute that -3. And when I distribute a -3, this becomes -3a plus 12b minus 27a squared minus 6b. Now, combine like terms. You would think you combine these, but this is an a, this is an a squared, right? They don't have the same degree or exponent, so you can't combine those. But we do have a b and a b, which we can combine. So this 12b minus 6b is going to give you positive 6b. Now we go from greatest degree to least degree, so we go -27a squared first, because that's the highest degree, minus 3a plus 6b. You could have rearranged these because they're technically the same degree, doesn't matter, but this is going to be my standard form. Next, I'm going to classify this. So what's the term with the highest degree? That would be this one. So it's going to be a 2nd degree or quadratic, and then 1, 2, 3 trinomial again. Nice. Part C, we're doing the same thing here, looking for like terms. We have the j to the 6th and the j to the 6th. Sweet, those are like terms. And then we have the j and the j, those are also like terms. So if I were putting this in standard form, let's do the j to the 6th first. What's 10j to the 6th minus 3j to the 6th? That's 7j to the 6th. And then next, we do the j's. 9j minus 4j is going to be 5j. Now, if I were to classify this, the term with the greatest degree would be this one. So it's going to be a 6th degree, and there's no term for 6th degree. We just say 6th degree. and there's two terms, so that would be a binomial. Here, combine like terms, just like we were doing. The x cubed is going to combine with the x cubed to make 2x cubed. The x squared is going to combine with the negative 4x squared to make negative 3x squared. And the negative 1 and the 1 are going to combine to cancel each other out. So we're left with 2x cubed minus 3x squared. And if I wanted to classify this, we look for the term with the greatest degree. That would be this one. So it's going to be to the third power, so cubic. And then there's two terms, so that would be a cubic binomial. Sweet, you're done.